Hi everyone, in this video we're talking through task 12.8. So we are going to be looking at coordinate geometry and how we use that to find what types of quadrilaterals we have and everything that we talked about in task 12.7. So finding your slope, finding the distance between 2 points, and also using the midpoint between points. We're going to use that to justify the properties of quadrilaterals that we have. So go ahead and flip to page 54 if you are not there already, and we will go ahead and get started. So the key ideas we're going to review before we jump into our coordinate geometry are parallel lines and perpendicular lines and what their slopes look like. So parallel lines have equal or the same slope. So if we have two lines like this, remember your parallel lines never touch each other. So if I have line A and B, line A is parallel to line B. An example of the slope of these points, remember we use M to represent our slope, so I'll say M sub A, so the slope of line A is equal to, let's just call that 2. If I know the slope of line A is 2, then the slope of line B also has to be 2 because those are parallel, they have to be equal to each other. Right, perpendicular lines have opposite reciprocal slopes. So opposite and reciprocal slopes. So remember that opposite means we change the sign, and then reciprocal just means that we flip the fraction that we have. So let's take a look at an example here. If we have lines A, and then we'll call this C here, line A is perpendicular to line C if they make that 90-degree angle where they intersect. So if, again, the slope of line A is equal to 2, then the slope of line C is going to have to be opposite. So instead of positive, it's going to be negative, and then it's the reciprocal. So this slope of A is like 2 over 1. Remember, if there's nothing in the denominator, it's just over an invisible 1. So flipping that fraction would put 1 in the numerator, 2 in denominator. Whoops, that was supposed to be my negative. So negative 1 over 2. There we go. That's going to be our slope for line C. Right, so again, those are opposite reciprocal of each other. So 2 and negative 1 over 2 will be our slopes of our perpendicular lines. Right, so let's use these ideas to talk about coordinate geometry and how we classify our quadrilaterals. So we want to figure out what best describes the quadrilateral below using our distances, our slopes, and our properties of quadrilaterals. So let's first take a look at the slope of these lines and see if these sides are parallel to each other or perpendicular to each other. So we can take a look at these in order. For example, let's just start with side AB. So the slope of side AB, again, I'm using M for that slope and just saying what side we're taking the slope of in parentheses. So slope of side AB is equal to, well, I go up by 2, right by 1. So this is 2 over 1, simplifies to 2. Slope of side BC is up by 1, right by 2. So that is 1 over 2. That won't simplify anymore. The slope of side CD or DC, I will also have 2 over 1, which simplifies to 2. And then our last side here, our slope of side AD, we're going up by 1, right by 2, so our slope is also 1/2. Right, so what you might notice from this is that we have side AB is parallel to side CD because both of those slopes are 2, and side BC is parallel to side AD because both of those are 1/2. But I do know that these are not perpendicular because they are not opposite of each other. So they are the reciprocal, but they're not opposite. They're both positive. So these sides, none of them are perpendicular to each other. So these angles are not going to be right angles. So I know then that this can't be a rectangle or a square. Okay, but let's see, then we kind of know that this has to be either a parallelogram or a rhombus. So what we're going to do then is find the length of each of these sides to see if they're all congruent, then this is a rhombus. So let's take a look at the length of side AB. So the length of side AB squared, remember we have our right triangle here, so we can use Pythagorean theorem. So the length of side AB squared is equal to 2 squared plus 1 squared, those two legs there. That's going to simplify to 4 plus 1, which is equal to 5. So solving for the length of AB, we take the square root of both sides, get length of AB is equal to the square root of 5. Our next side that we have is BC, so side BC squared is equal to 1 squared plus 2 squared. This will give me, these are the same numbers as above, so this will also tell me the length of side BC is equal to the square root of 5. Setting this up for all of our other sides will actually show us the same thing. So length of side CD is also equal to 2 squared plus 1 squared. So I get CD, the length of side CD is equal to the square root of 5. I'm going to move this down for us so we have enough space. And then our last side, whoops, I wanted that to stay. Okay, so our last side, AD squared was also equal to 1 squared plus 2 squared. So side AD equals the square root of 5. So what we get from this is that the length of all of these sides, side AB, side BC, the length of side BC, length of side CD, and length of side AD are all equal to each other. So all of these sides are congruent. So in my takeaways, I have that my opposite sides are parallel and all sides are congruent. So this quadrilateral ABCD is a rhombus. So again, what we looked at there was the angle between those sides and then the length of those sides. So that's kind of what you'll always need to look at with our coordinate geometry, is the lengths and the angles. Are the lengths the same or not? Are the angles perpendicular or not? Okay, so let's go ahead and look at our next example here. This one's a little bit different. So instead of being given the sides of our quadrilateral, we're given the diagonals. So we want to figure out what name would best describe this quadrilateral. So before we start, I'm going to name these points just so we know what we're talking about. So we'll go A, B, C, and D around our quadrilateral. So let's start by looking at the slopes of these diagonals. So my first diagonal here, we'll look at AC. So the slope of this, I'm going down by 4, so that's a -4, right by 2 here. So the slope of side or diagonal AC is equal to -4 over 2, which simplifies to -2. Our second diagonal here, my slope is going up by 2 first and then to the right by 4. So slope of diagonal DB is equal to 2 over 4. So this simplifies to 1/2. So what I get from this is that side AC, or diagonal AC, is perpendicular to diagonal DB. Okay, so since those are opposite reciprocal slopes. All right, so we know that those diagonals are perpendicular to each other, so this has to either be a square or a rhombus, since those are the only quadrilaterals with those properties. So let's see if those diagonals are congruent to each other. If they are congruent, then we know it has to be a square. So the length of diagonal AC is equal to, our first leg is 4, our second leg is 2, so 4 squared plus 2 squared. So the length of AC squared is equal to 16 plus 4. That'll simplify to 20. Take the square root of both sides, and we get the length of AC is equal to the square root of 20. Alright, and then we want to find the length of our other diagonal. So length of DB squared equals 2 squared plus 4 squared. You could go ahead and simplify this, but it's the same numbers we used above, so we'll get that the length of DB is also equal to 20 once we simplify that. Alright, so this tells me that the length of those two diagonals are equal to each other, right? So the length of AC is equal to the length of DB, so then I know that those two segments are congruent to each other. So basically taking these two different properties and putting them together, I know that the diagonals are perpendicular and also congruent. So this quadrilateral ABCD has to be a square. Again, you can kind of use process of elimination once you find out one property to see what else you need, or to see what quadrilateral you have to be using for this different information that we're given. Alright, so go ahead and try the next one here. Pause the video, try this on your own, see if you can get what kind of quadrilateral would this be. Again, take a look at the lengths of the sides and the angle that's made between the sides. Alright, so hopefully you got a chance to try that. If you want, you can skip ahead to check your answer, but I'll also walk us through this. So first thing I'm going to look at is the slope of these sides to see if they're perpendicular or not. So when you find those slopes, the slope of side AB will be 3 over 3, which simplifies to 1. Slope of BC is going to be equal to negative 2 over 2, which is negative 1 when we simplify that. Slope of side CD is going to be equal to 1, and the slope of side DA or AD is also equal to negative 2. So what we get here is that I can see that side AB is perpendicular to side BC because those are opposite reciprocal slopes. I also see that side AB is perpendicular to side AD or side DA because that's also negative 1. And then we can also see side CD was perpendicular to side BC. And similar as above, side CD was also perpendicular to side AD. So I know that all of these angles here have to be right because those sides are all perpendicular to each other. So then I know that this has to be either a rectangle or a square. So let's see if those sides are congruent, if they're equal to each other or not. So we'll look at the length of side AB. Setting this up, we get AB squared is equal to 3 squared plus 3 squared. Again, looking at that right triangle that's made here. So this will give us that the length of AB is equal to square root of 18 after you simplify that. And then we can look at the length of DC. Once you calculate that, you should get the same length as the square root of 18. We want to take a look at our other sides. So the length of BC is equal to 2 squared plus 2 squared. Simplifying that will give us the length of side BC is equal to square root of 8. And then doing the same thing to find side AD. The length of side AD will also be equal to the square root of 8. So what do you notice about what What do you notice about these two sides? Good, so you see that the length of side, that side AB is congruent to side DC or CD, and then we also have side BC is congruent to side AD. So I can mark that on my diagram. I know my opposite sides here are congruent to each other, but not all these side lengths are congruent. So all we know is that opposite sides are congruent, and all those angles are 90 degrees. Again, that's because those sides were perpendicular. So the quadrilateral ABCD is a rectangle. Again, since we didn't have all sides congruent, it wasn't a square, so this has to be a rectangle. All right, go ahead and try the next one here as well. This is one with our diagonals. So go ahead, pause the video, see if you can figure out what kind of quadrilateral this is. All right, so hopefully you're able to give this one a try too. Again, we can take a look at the slope of these diagonals. So let's take a look at the slope of side AB, or the slope of diagonal AB. I'm going down by 3, right by 4. So my slope is -3/4, and that won't simplify. The slope of side or diagonal CD is going to be equal to, well, I go up by 3, right by 2, so 3/2. Alright, so these are not perpendicular, so AB not perpendicular to side DC, segment DC. Okay, because those are not opposite reciprocal. Alright, so we know that they're not perpendicular, so it cannot be a rhombus, it cannot be a square. Let's go ahead and take a look at the length of these to see if it's a rectangle. If the length of both of those diagonals are congruent, then we know it's a rectangle. Okay, so the length of side AB is going to be equal to, or the length of side AB squared is equal to 3 squared plus 4 squared. So length of AB squared equals 9 plus 16. That simplifies to 25. You can take the square root of both sides, and you might have noticed this is a Pythagorean triple. So if you did that, that'll save you some time. So the length of AB is equal to 5. Okay, the next thing we're going to look at is the length of our other diagonal. So the length of side CD is equal to 3 squared plus 2 squared, right? We have our right triangle up here. Whoops, and I forgot, this is CD squared equals. So then the length of CD squared equals 9 plus 4. So then we get this is equal to 13. Take the square root of both sides, and we get CD equals 13. Square root of 13, sorry. So don't forget your square root there. Okay, so what we get from this is that those two diagonals are not congruent to each other. They are not equal in those lengths. So I know that this is not a rectangle because those lengths of the diagonals aren't equal, and this wasn't a rhombus or a square since those diagonals weren't perpendicular. So we do want to check then, is this just a quadrilateral or is this a parallelogram? So one of our properties of parallelograms is that the diagonals bisect each other. So let's see if these diagonals have the same midpoint. Then we know that then we know that those diagonals bisect each other if they have the same midpoint. So let's take a look at the midpoint. Kind of make a little box for us here. So the midpoint of segment AD, that's going to be equal to, well, our first coordinate up here is 3, 4, and our second coordinate is 7, 1. So my midpoint is 3 plus 7 over 2, 4 plus 1 over 2. This will give me 5, 2.5. I'm going to erase that there. 5, 2.5 for our midpoint of that first segment. Okay, so the midpoint of our second segment, our second diagonal, is going to be, our first point here is 4, 1. Our second point is 6, 4. So I will have, adding my x's together, 4 plus 6 divided by 2, comma, our y's, 1 plus 4 divided by 2. This will give me my midpoint also at 4, 2.5. So I can see my midpoint would be right here where those two segments are meeting. So the diagonals bisect each other, but are not perpendicular or congruent. So A, D, B, C. Be careful when you're naming this quadrilateral because, again, the order is a little bit different. We go from A to D to B to C. So remember, you got to follow that order. We can't just jump across to B. So quadrilateral ADBC is a parallelogram. Again, that's the most specific we can be based on all of those properties that we looked at. All right, so that is it for this task. Go ahead and try the Ready, Set, Go. And as always, stop by the Learning Lab or office hours if you have questions.